This is SAT practice packet number 11, problem number 8. The area of rectangle ABCD is 96 and AD is 2/3 of AB. Points X and Y are midpoints of AD and BC respectively. If the four shaded triangles are isosceles, what is the perimeter of the unshaded hexagon? So our ultimate goal is to find this perimeter of the hexagon. Okay, so let's take a look at the rectangle that they gave us. Now there's a lot of information here and we want to take it part by part. So the first thing it says is the area of the rectangle ABCD is 96. So if you look in the front of your packet, the area of a rectangle is length times width. Okay, so here they're telling us that our length times our width, is going to give us 96. Okay, so now let's keep on reading. Now it says AD is 2/3 of AB. So if we take a look here, AD is 2/3 of this. So that means that this side is going to be 2/3 of the length. Okay, so this side is 2/3 of the length. Now, that information is going to help us to figure out what L has to be and what W has to be in order to get 96. So the first thing, there are two ways that you can figure out the values for L and Y. The first way is by trying to see what your L times W is going to be. We know we want to get to 96, so let's find some factors. We can say that our width is 1 and 96. Now I put the 1 on the width because the width here represents a smaller distance. So 1 times 96, or 2 times 48, or 3 times 32, or 4 times 24, or 8 times 12. Those are my factors of 96, my integer factors of 96. Now here we only get integers, but it's very likely that our width and our length are going to be integers, so that's okay. So now we want to figure out a width that's 2/3 the length. Well, if you look at our choices, 1 is not 2/3 of 96, 2 is not 2/3 of 48, 3 is not 2/3 of 32, 4 is not 2/3 of 24, but 8 is 2/3 of 12. If you break down 12 into thirds, it's 4. 2/3 is 8. So we know that our length has to be 12 and our width has to be 8. So that's one way of finding it. If you're more of an algebraic thinker, then we can algebraically solve this. We know that the length is just length, and we know the width is 2/3 of the length, and that has to equal 96. So now we just do some simple algebra. 2/3 L squared, because L times L gives us L squared, equals 96. I'm going to multiply both sides by 3. I get 2L squared equals 288. Divide both sides by 2. L squared equals 144. Take the square root of both sides. L is going to equal 12. Well, if L is equal to 12, then 2/3 of 12 has to equal our width. Here, 2 times 12 is 24. 24 divided by 3 gives us 8. So we found that the length is 12, the width is 8, and that's exactly what we did by finding the factors 12 and 8. Okay? So we're done with this very first part, figuring out the length and width that gave us an area of 96. Now let's move on to the next important piece of information. Point X and Y are midpoints of AD and BC. So that means that in our diagram, this X represents the midpoint between A and D. So that means that this part is the same as this part. Well, if the whole thing is 8, that means that this has to be 4 and this has to be 4. Okay? And we can do that on the other side as well, because it's just a rectangle. So we can, this side is 8, this side is 8. 4, 4, 4, 4. Now let's read the next piece of information. The 4 shaded triangles are isosceles. Isosceles means that 2 of the sides are the same. So here we notice that we have right triangles. So if this side is 4, then the other leg is also 4. Because remember, the hypotenuse is the longest side. So 4, and then another 4, 4, 4, 4, 4. Okay? So from here to here we have 4. From here to here, 4. From here to here, 4. 4. 4. 4. 4 and 4. Okay? All right, so now we need to figure out the answer to the actual question. What is the perimeter of the unshaded hexagon? So our goal is to find this perimeter. So let's start with the easy parts. We know that the entire length is 12, so if this part is 4 and this part is 4, that means that this center part has to also be 4, because 4 plus 4 plus 4 gives us 12. Same thing on the bottom. We know that this whole bottom part has to be 12. So if that's 4 and that's 4, that means that this center part has to be 4. Okay? So now our goal is to figure out these hypotenuses. So here is where our right triangle theorems can come in handy. For example, the Pythagorean theorem. You can do Pythagorean theorem 4 squared plus 4 squared equals c squared and figure out what that is. Or you can simply use your special right triangles. So here, if 2 sides are the same, and this is 90 degrees, that means we have a 45, 45, 90. So if the 2 sides are 4, the hypotenuse is 4 square root of 2. And that's a fact that's given in the, it's given in the front of any SAT math packet. You're going to have a little, what is it called? A reference sheet. And that's this 45, 45, 90 triangle is in that reference sheet. So if you forget, you can reference back to that, or you can just work out the Pythagorean theorem. Remember, 4 squared plus 4 squared is equal to c squared, and then you just do the algebra to figure out that we have 4 square root of 2. Well, all of these are the same, so that means that all of these are going to be 4 square root of 2. So now we know all the sides. Now it's about adding them all. So here we have a 4 plus 4 square root of 2 plus 4 square root of 2 plus 4 plus 4 square root of 2 plus 4 square root of 2. And we already counted that one, so we're done. Now it's just about combining the like terms. We have a single 4 and a single 4, so 4 plus 4 is about adding the like terms. So here we have 4 plus 4, that gives us 8. And then we have all these square root of 2's. So we have plus 4 square root of 2, plus 4 square root of 2, plus 4 square root of 2, plus 4 square root of 2. So 4, 8, 12, 16 square root of 2. And we're done. That's the perimeter. Now if you look at your answers, they don't simplify it. They just leave it like that. So here our answer is going to be D, 8 plus 16 square root of 2.